So on that worksheet, like I said, we're going to talk through the answers through these questions 1 through 10. All right. So on the worksheet, there's a diagram first, and it wants you to label 1, 2, 3, and 4. What are the parts of that wave? And hopefully when you look at that wave, you should know that that S-shaped wave, that's a transverse wave. So you should easily be able to fill in what each of those numbers are representing. Number 1, that's the high point of a transverse wave. That would be a crest. Number 2, that's the low point of a wave. That would be your trough. Number 3, that is measuring the distance between the resting position, that flat horizontal line, and a trough. That would be amplitude. That's the answer for number 3. Remember, amplitude could also be measured from the resting point to the crest, okay? So it can be resting point to crest or resting point to trough for measuring amplitude. Number 4, you should see that that's measuring wavelength. What is wavelength? Wavelength is where you measure the distance between one point on a wave and the identical point on another. So it could be crest to crest or trough to trough. If I had a figure of a sound wave, measuring wavelength could be compression to compression or rarefaction to rarefaction. It does not matter the type of wave that you have to measure wavelength. Okay, so I want to stress that as well. If you take a look on that answer key, number 5 is saying list 3 characteristics of a wave you can measure. We can measure of a wave, we can measure amplitude, light or sound. We can measure wavelength of a light or sound wave. We can measure frequency of a light or sound wave. And I also added wave velocity. That is something that we can also measure with a wave. Number 6 says what is meant by the frequency of a wave and what is the unit for frequency. Now remember, frequency is classified as the number of waves, the number of complete waves that pass a point each second. The unit for frequency is hertz, Hz. Number 7 states if we have the frequency of a wave and we notice it to increase, what is going to happen to that wave's wavelength? Again, going back, remember, to the electromagnetic spectrum, those high frequency waves, X-rays, gamma rays, you should have noticed that as you increase frequency, the wavelength becomes shorter. Then that, again, should make sense because if you have a high frequency wave, more waves are passing a point each second. In order for that to happen, the wavelength needs to be shorter. That distance between each of the waves needs to be a small value to have a high frequency wave. Okay? Moving on that wave properties worksheet, there's a table here that you would have had to fill in looking at a transverse wave and a compressional wave. And it's asking you, how would you measure wavelength? How would you measure amplitude of those two types of waves? Transverse waves, remember, is light, your S-shaped waves. Compressional waves, remember, are sound. Think of slinky type waves, okay? So to measure wavelength of a transverse wave, you can measure it crest to crest, or you can measure it trough to trough. To measure wavelength of a compressional wave, it's compression to compression or rarefaction to rarefaction. As long as you realize that to measure wavelength, it needs to be from one point on a wave and the identical point on another. To measure amplitude of those two types of waves, now that's different. To measure amplitude of a transverse wave, a light wave, you have to measure it from the resting position to the crest or the resting position to the trough, okay? But to measure the amplitude of a compressional wave, that again is different, that's sound. To get the amplitude of a sound wave, you have to measure the thickness of the compression. So that is a difference between light and sound waves and how you measure amplitude. Number 10, this is going back to our equation, the only equation that we have for light, okay? Velocity is frequency multiplied by wavelength. In this sample problem, we're asking you, what is the velocity of a wave that has a frequency of 6 hertz and a wavelength of 2 meters? Remember, velocity, wavelength multiplied by frequency. So in order to calculate the velocity in this example, we would take 6 hertz multiplied by 2 meters. Wave velocity would be 12 meters per second. And I added that triangle on this slide for you to help. Again, you will have plenty of practice next week with this equation. We're going to have practice problems and a PhET simulation looking at wave velocity and calculating wavelength and frequency. So again, you'll have plenty of practice, okay? All right, my next slide here, this is stop, okay? So this is where I want you to stop, again, this video. This is the point where now I'm going to ask you to take the information that we just talked about, that maybe you are taking notes on at the same time. This is where I want you, if you are regs, okay, regular physical science, I'm going to stop you here. You're going to head to Canvas. Just like in class, you are going to find choice notes linked in Canvas. Light properties, I believe, is what the name of the choice notes in for this week. What you're going to do for your second weekly assignment for regular physical science is you are going to complete the wave properties and light choice notes. You can do exactly what we did in class. If you want to, take the Google document that's provided, print off a copy, write on it. If you want to type, make a copy of that Google document and type on it itself. Either way, whether you're writing or typing, you are going to submit the choice notes into Canvas for your second weekly assignment. These choice notes are going to be due, again, Friday, April 17th by 3 p.m. Okay, so again, you can take a picture, or you can take a picture of your choice notes, send me a copy, whatever, but submit it into Canvas. I'm stressing submitting into Canvas because I get so many emails in one day. I don't want to take the chance of having your assignments getting lost in the shuffle of all the emails that I get from questions from you, from parents. So please try your hardest. Submit your assignments into Canvas. I'll have 2 assignments created. One, electromagnetic spectrum video guide. The second will be light properties, wave properties of choice notes. Okay, so 2 assignments for regular physical science you are going to submit. For my honors kiddos, all right, your 2 assignments are pretty similar. Your first assignment is going to be the electromagnetic spectrum video guide. You will submit that. But for my honors kiddos, you are going to be responsible for, instead of submitting choice notes, you are going to submit chapter 26 reading review questions. These reading review questions are also due by 3 p.m. Friday, April 17th, okay? So both groups, honors and regular physical science, both of you are going to submit the video guide for electromagnetic spectrum. Honors, you're submitting chapter 26 review questions. Regular physical science, you are submitting light wave properties choice notes, okay? So here's the stop. You can stop the video. Again, if you've got questions on anything, please feel free to ask. Email me. I'll get back to you as soon as possible. But I really do think this week's assignments are pretty straightforward. Watching a video, taking notes, and working on choice notes or reading review questions. Okay? Good luck, and I will look for those submissions again, 3 p.m. Friday on April 17th. Good luck again with week 3 online learning, not only in science and all of your classes. Please be patient, work hard, and always, always be checking Canvas every day, not just for science, but for all of your classes. Because if I'm going to have an update, if I'm going to have an announcement, that's where I'm going to be submitting it, is in Canvas. Just make it a habit. That's where you have to go at least once every day, maybe twice, just to make sure that you're getting all those updates. Okay? Again, thank you, good luck, and I miss each and every one of you. But enjoy this new journey of light and looking at waves and their properties.